Okay, colligative properties. These are properties of pure liquids that are changed when solute is added. And how do they affect it? Well, they're going to increase the boiling point. They're going to decrease the freezing point or the melting point, and they're going to increase the vapor pressure. Basically, the liquid state is bigger. You're a liquid over a larger range of temperatures. Why does adding salt to water, why does it elevate the boiling point? So a water molecule that wants to turn into a gas, that water molecule needs to be moving up when it's trying to leave the liquid. When it does that, there's going to be other water molecules around those other water molecules are going to be attracted to that water molecule. So what you'll see is this oxygen being attracted to that hydrogen and being attracted to that hydrogen. If the water molecule is moving fast enough, it will break free of those intermolecular forces and turn into the gaseous state. And that happens at 212 degrees. Well, what happens if my water molecule is not interacting with partial positives and partial negatives, but it's interacting with, say, a chlorine? So the chlorine's got a negative charge on it. So the interaction between the intermolecular force here is much larger because this thing right here is a full-fledged -1 charge. Where, I'm sorry, my bad. Let me change that. Let me change that to a sodium, a full-fledged positive charge. So that's got a +1 charge on it, where this hydrogen over here, it only has a partial positive charge. So this intermolecular force is going to be much stronger than this intermolecular force over here. So the water molecule is going to have to be moving faster. The kinetic energy is going to have to be higher. So that means the temp's up. Freezing point depressed. Okay, so water molecules form these nice hexagonal structures that interlock with each other. Obviously not a good drawer. Let's see, about like that, whatever. Anyway, and each of these water molecules, there's a hydrogen and an oxygen forming an intermolecular force. If I put a sodium in here, all of the oxygens are going to flip themselves around to face the sodium. And when they do that, that's going to disrupt, it's going to mess up the crystal matrix. So a solid is an organized structure, and now that the crystal matrix structure has been messed up, it's liquid. What's the Fahrenheit freezing temperature? All right, of 2.5 molar solution of magnesium chloride. So that equation, what are we doing? Freezing point. All right, so the temperature change of the freezing point is N Kf molarity. And we're talking about magnesium chloride. So magnesium chloride is MgCl2. That thing breaks apart into magnesiums and chloride. So the N for this is going to be 3. The Kf for this thing is going to be 1.86 degrees C molar, and the solution concentration is molar. All right, so I've got times 1.6, so I get 13.95 degrees Celsius. So the temperature change is 13.95 degrees Celsius. That's the change. So that means the new freezing point is going to be negative 13.95 degrees Celsius because the freezing point of water is 0. So now what's the new freezing point of water in degrees Fahrenheit? So that would be negative 13.95 plus 32 times 9/5. All right, let's see if this makes sense. All right, so plus 32 times 9 divided by 5. Well, that doesn't make any sense. I think I did that equation wrong. Just a sec. Yeah, I got this backwards. It's times 9/5, then add 32. So what's this work out to be? .89 degrees Fahrenheit. All right, that makes sense. All right, list the following in order of most effective to least effective at reducing the freezing point of water. This guy here is going to separate into a sodium and a bromide. You're going to separate into a potassium and a nitrate. You're going to separate into a calcium and 2 chlorides, and you're going to be BaSO4. You're insoluble, so you're going to not separate. So this is 1 particle, this is 3 particles, this is 2 particles, and this is 2 particles. So the N for this one would be 3, so the most effective at reducing the freezing point would be this calcium chloride. This one's kind of silly, but you make water electrolytic, meaning you add ions. So you'll end up having electricity flow through you because you made the water conductive.